Okay, so this is section 4.1, and it's talking about polynomial functions and graphs of them. So here is just the form of a polynomial function. Okay, and what all this is saying is that we have this, and then that might be an x to the third, and maybe plus 5x squared. It's decreasing the powers until we get here. Notice this one doesn't have a variable x on it. So that is going to be your constant. So when we look at just this form, and I want to know what is the leading coefficient, that's the number that falls, maybe it's rational, irrational, but it's whatever falls in front of this x, your highest degree, which is your highest power of x. So in this case, your leading coefficient here is a sub n. Now, which of these is a constant term? Well, it's the one at the end, because we write it in descending order where your powers get smaller. And so it's the one that doesn't have an x on it. So your constant term is a sub 0. And then if I were to go through, and we learned this already in our chapter 3, but if I go in and put a 0 in for all of these x values, this right here is going to be the y-intercept, right? So I find this p of x is the same thing as y equals. I can interchange them. So y equals all these different values of x, powers of x. If I put a 0 in for all of these x's, then all that's left is this constant. So the y-intercept is a to the 0. So let's just look at an example. Let's say I have, and remember this p of x, that's just, that can be f of x, t of x, s of x. It doesn't matter. So don't get confused on whatever this letter is. This is just function form. It doesn't matter what variables used right there. Okay. So let's say we have negative 4 x to the 4th. Let's see. All right, so let's say we have this. So notice what we're doing in chapter 4 is we're starting to work with these higher order functions. And we've just been working lately with just the x squared, the quadratics, the parabolas. Right now we're starting to do some higher order things, okay? So if I asked you these same questions, so what would be the leading coefficient? Well, the leading coefficient here would be, here's my highest degree, descending order. It's going to be this number right here. So it's going to be negative 4. It's going to be that integer. Okay, so what is the constant term? Well, what is the one that doesn't have an x? It should be at the very end if we write it in descending order. It's a negative 10. Don't forget to include the sign with it. And then what is the y-intercept? Well, if I put a 0 in for this and this and this and this, they all become 0. So whatever your constant is going to be whatever your intercept is. So it's negative 10, but the y-intercept is where it goes through the y-axis. So you would want to write that as an ordered pair. Excuse me. Okay. All right. So let's take a couple graphs here and some examples of graphs. So when we talk about a quadratic, that is an x squared graph. So those are going to look like parabolas. These are what we're dealing with now. Okay, we're not dealing with anything sideways. We'll talk about those another time in another class. So that's a quadratic, which is x squared. Okay, now a cubic then is anything to the third power. So I always kind of think that looks a little bit like a chair. So it's kind of like this. And it kind of depends which way it goes. It can go either way, depending if it's positive or negative. We're going to talk about that. But that's kind of a cubic function. And I didn't draw that super great, but it kind of looks like a chair. So a quartic then is something that looks maybe like a W. Maybe something like this, just depending. We don't really know. So what we know is we don't always know what goes on in the middle here. We don't know what's going on, but we can talk a little bit about what a quartic function looks like because we know it's something like this. All right, but so if I have like an x to the 8th, well, x to the 8th are going to have these same end behaviors, but we don't know really what happens in the middle here. So I'm going to talk about that also in just a second. So let's look down here at absolute and local extremas. Okay, what extremas are, see if I can get this so it's not crooked for you. There we go. Extremas are like your maximum and your minimums, okay? And remember when we talk about max and min, that's your y value, right? That's how high it is or how low it is. So extremas really are your y values. So if I want, first of all, let's talk about a local, All right, so here is a chordic function. Can you recognize it looks like a chordic function? Okay, and notice it has two minimums. Those are your low points, right? And it has one maximum. Well, a local extrema, so this would be a local minimum. So I'm just going to kind of label that one as a local minimum. Now notice this one is lower than this one. It's the absolute lowest point of the graph. So this is going to be the absolute minimum. Now recognize it takes two minimums to have an absolute because one has to be absolutely lower than the other. Or if it's a maximum, one would have to be absolutely higher than the other. So it takes two of them to have an absolute. So if I look here at the maximum, this is a high point in my graph. Okay, this one is going to be a local max. But I don't have an absolute maximum because I don't have another point that is higher than that. These go on infinitely without bound, meaning they never stop. So those cannot be absolute maximums. All right, so because I only have one maximum, we just call that a local max. And so this would be a local max at D, because that's the Y value. That's a CD if you can't read it. Okay, this is an AB, so I'd have a local min at B. It's whatever this Y value is. And here I have an absolute min at H. That's EH if you can't read it. So that's how I would write it. So looking over at this one, trying to get this to zoom in a little bit better, but I can't get much better. This is an MN and this is a JK. So kind of think to yourself, what do you think? Are you going to have local, absolute, maximins? What do you think you're going to have? So looking here, we have one minimum, correct? And then this goes on without bound infinitely. So we will have a local minimum at the Y value, which is K in that ordered pair. And then this right here would be a local maximum at the Y value, which is an N. And I don't have an absolute max because I only have one max, one min, and these go on without bounds. So again, to repeat that, you have to have two of these or three or more to have an absolute min or max, okay? All right, so now the number of local extremes. So I want you to take a look at, like if I just have a linear function, which is a straight line like this. Okay, if I just have that, then do you agree there's no max or mins in there? Because there's no turning points, which are what these are kind of called. There's no turning points in there. So that's a degree one, doesn't have any local extrema. Okay, now if I have a parabola, so let's look up here at a parabola. I guess I can just look right here. So here's a parabola. You can open up or down. How many extremas do I have there? Well, I've got one, and it's a minimum. I could have this, and I would have one maximum, but I just have one minimum there with a degree 2. A degree 2 is a quadratic, a parabola. Okay, so a degree 3 we kind of talked about is this. Sometimes it looks like a chair. This is a little bit more, it shows it a little bit better with the turning points. So here, this is a degree 3, and it's got 2 turning points, right? So it's got 2 either extrema, local extrema, max or mins. So if it's a degree 3, you have 2 extremas. If it's a degree 2, then you have 1 extrema. If you have a degree 1, you have 0 extrema. So let's look at a degree 4. That's like the W, either one here. So if I have a degree 4, how many extrema? 1, 2, 3. 3 turning points. So there's 3 extrema. Now, the thing is, it's at most 3. Okay, it's not always going to be exactly 3 because this hump may come clear down here, and we may not have another turning point in there. So we always say a chordic function has a degree 4 with at most 3 extrema. It can't have more than 3. All right, it could maybe have less. It could flatten out. So we want to use the word at most when we talk about that. All right. So that is local and absolute extrema. Don't make it hard. It's just your maximums, your minimums. Okay. And remember, that's always your Y value. And that's kind of, so kind of what we summed up over here is that the number of turning points of the graph of a polynomial function when n is greater than or equal to 1, that just means the power is greater than or equal to 1, is at most n minus 1. So if I have a degree 2, the most extrema is going to be 1. Do you see where we take n minus 1? 3, okay, then the most amount of extrema is going to be 2. So if I had a higher degree that was a degree 7, then at most I could have 6 extrema at most. Doesn't mean I'm going to have 6. I might only have 4, but I could have at the most 6. If I have a degree 10, I can have at the most 9 extremas for that. All right. So moving on, let's talk about end behavior. So end behavior, here again is your function, your polynomial function there. And so what we talk about here on end behavior is just, we don't always know what's going to happen in the middle of this. So we might have a degree to the 10th power. Doing that, we can determine the end behavior, but we can't really determine what's going on in the middle here. Okay, we can't, the action that's going on in here, but we can determine the end behavior. So that eventually helps us graph. That's what that eventually is going to help us when we get a little bit more advanced. I don't think we do too much with it here, but when we start graphing more, we would use the end behavior. So let's see. So let's say we have something like this and we have an odd degree. So I'm just going to write an example here. So if I have an odd degree, let's say 3x to the third, doesn't really matter what the rest of it is. Okay. All we really look at is this when we talk about end behavior. So this is your A. See right here, this is your A to the end. This is your A. As long as it's written in descending order, that's super important. All right, so if this A is greater than 0, it just means if it's positive, then your behavior is down left, up right. So you can write it like this. Or you can say down left, up right. However you want to write that. Okay, usually we'll see the pictures in what we're doing now, but it's okay if you say down, left, up, right, but be sure you do know the pictures because that's probably what you'll see in your assignment. Now, if, and how I kind of remember that is I just kind of think of like a positive line, like that's a positive slope. So if it's positive, it begins down and ends up right, down, left, up, right. So if A was negative, so let's say we had a negative 2x to the, let's make it a different odd, to the 5th. Plus x to the 4th. In this part, it just doesn't matter because this is all we look at. All right, so I don't really care what this is. So we have an odd degree and A is negative, right? So here's A is negative. So this is when A is greater than 0. So when A is negative, it's just the opposite. It starts up left and it goes down right. So up left and down right. Again, just be sure you can do these, okay? And so that's that, if you can just remember that. So remember, just think of it like a negative slope. A negative slope is up left, down right. So up left, down right. So if that helps you a little bit, and that's only with odd. So that can be an x to the 3rd, an x to the 17th. It doesn't matter. It's just looking at this coefficient in front of that odd. All right, so now let's look at even degrees. So an even degree would be something maybe x to the 4th. Let's do a 5x to the 4th plus x to the 3rd plus, it doesn't matter from there. So we're looking at this leading coefficient. Our A is positive, right? It's a positive 5. So if it's positive, then it goes up left, up right. Doesn't matter as long as this is even. It can be, so let's do another one. So let's say we have a negative 7x to the 22nd plus x to the 21st plus blah, blah, blah. Doesn't matter. Look at this. All right. So our A is negative. So A is less than 0. And if A is less than 0, if this number is negative, it doesn't matter as long as this is even. If this is negative, we know the ends are going to go down left and down right. So if your highest power is even and the leading coefficient is positive, it's going to be up, up. If it's negative, it'll be down, down. It doesn't matter if it's an x to the 4th or an x to the 22nd. We're not talking about what goes on in the middle here. We're just talking about the end behavior. So if it's odd, they're going to go opposite directions. Okay, if it's positive, it's kind of like a positive slope, down, left, up, right. If it's negative, up, left, down, right. So you need to memorize those, kind of get them down. So let's look at practice here. I hope you can see these, but all you really need to see is, try and zoom in a little bit better. I think that helped too much. This is an x to the 4th. Okay, so thinking about an x to the 4th, just think to yourself, what is that going to look like? It's an even power, an even degree, excuse me, even degree, and it's got a positive leading coefficient. This is a positive 1. All right, so it's an even degree, so it's going to be up, up. So I look at all of these, and which is the one that goes up, up? It's letter C, so this would be C. Okay, so let's look at this one. This is 3x to the 3rd. So because it's odd, we know it's going to go opposite directions, the end behavior. This is positive, so think of a positive slope. I always kind of go, okay, positive looks like this. So it's going to be down, left, up, right. So which one gives us down, left, up, right? Right here. So that would be B. So over here we have a negative x to the 6th. Notice we don't really care about the rest of this. We just look at this as long as it's written in descending order. So negative x to the 6th, it's even. 6 is even. Now we have a negative a. So if it's even, they go the same direction. Because it's negative, it's going to go down, down. So which of these goes down, down? A. And then lastly, negative 7x to the 7th power, if you can't read that. So 7 is an odd degree. We got a negative leading coefficient. All right, so odd goes opposite directions. Negative, I always think again of a negative slope. Up, left, down, right. So that would be up, left, down, right, would be D. Okay. All right, so that's end behavior. Let's take a look now at analyzing this polynomial function here. All right, so if you want to just look at this and pause it and try and do it, you can. Go ahead and pause it. I'll go ahead and talk it through. So here is, we have an x to the 4th. Can't seem to get that to just, an x to the 4th. So let's talk about the end behavior for an x to the 4th. Even power, positive leading coefficient. So this answer is going to be up, up. Now don't connect it, okay, because we don't know what goes on in the middle. So it's just up, up. So if we talk about a domain on this, it's kind of like a parabola. So the ends, no matter what, I can look up here even on these, oh, I'm sorry, over here on this page, the quartics. So this is a quartic, which is a 4th power. See, they both go the same direction. These even powers go the same direction. These are even powers with the power of 2. They go the same direction. So the domain is, if I'm looking at something, well, maybe this is an easier one to look at. If I'm looking at something like this, what is that domain? Well, it goes on infinitely here, negatively, and it goes on infinitely to the positive. So anytime that you're going to have an even power, your domain is going to be negative infinity to positive infinity. Because those arrows go on infinitely, right? Okay, so what is the extrema? So I guess what my question on that is, how many extrema could you have? So if I have an x to the 4th, remember all I do is subtract 1 from that. So I can have at most 3 extrema. Now I don't know what they are until I graph it. I don't know if it's a maximum or a minimum. I don't know what they are, but I know that I can have, at the most, I can have 3. Because it's always your highest degree minus 1. That's how many turns you have, okay? And then lastly, a comprehensive graph. This will be something I will ask you. What is a good comprehensive graph? So really comprehensive graph means what is a good picture of a graph? So when I put it on a calculator, what should I be able to see to know that it's a good graph? So these are the 3 things I expect you to know on a comprehensive graph. First of all, you need to be able to see the extremas. So you need to be able to see your maximum and your minimums. Okay? You need to be able to see the end behavior. So can you see which direction your graph is going? And then the last thing for a good comprehensive graph is you need to be able to see the X and Y intercepts. So you need to be able to see where that graph goes through the X and Y intercept. So those are the three things that when I graph something on a graph, if I can't see those, it's not a good picture of a graph. So that means I have to adjust the window on the graph, all right? From your X values, from your minimum to your maximum on your X, and a minimum and a maximum on your Y. So you're gonna be asked that question, so be sure you know those three things and what they mean. All right, these are your max or mins. This is how your end behavior goes on your graph, on your function. And then this is where it goes through the X and Y axis. You need to see all those on a graph, okay? All right, so I'm waiting for you to answer back. Okay, so there's your 4.1. I hope you guys have a great day.